Alright guys, so today I'm going to help understand and simplify depth of field, focusing on infinity and how to take star trails. So it's going to be a fun video, so come along. So before we jump into the actual depth of field subject, I just want to visually show you what exactly depth of field is and how it impacts your everyday shots. To show you visually what depth of field is, we have to take help of a macro lens. In macro world, depth of field is so shallow and it's so pronounced that you can easily see it using a live view. So I'm going to show you right now what exactly it looks like. Alright guys, to show you depth of field visually, I have this macro lens focusing on my keyboard. You can see I have G key, F and H key, all are in focus. If I focus and if I change my camera lens focus a tiny bit, you'll see that the G and H key are completely out of focus, and I have some other keys T and Y which are in focus, which are further away from the lens. And if I go the other way, you'll see keys B and V which are in focus now. So in macro photography, the depth of field effect is more pronounced. As you can see, the keys above G are not visible or not in focus, and the keys below G are not in focus. So this lens, macro lens, has a super shallow depth of field that only some part of the picture will be in focus. And this is true for every single lens, even the regular lens, the non-macro lens. All these lenses have a range, a near point and the far point, beyond which your lens will not be able to focus on any subjects. Hope this is clear, and I'll see you soon in the next part. Alright guys, I hope you understand the meaning of depth of field. It's just the focal range between 2 points. One is called as a near point and one is called as a far point, in which your camera can focus and resolve these subjects. Now, every camera, every lens has its own focal range, near point and far point, and it also changes it also changes based on the f-stop that you're using to capture the scene. So if you have a lens that has f4 and it goes all the way to f22, 32, whatever number, for every f-stop, the focal range changes. So you cannot just simply memorize that, oh, for this lens, my near range is 3 feet and my far range is, let's say, 10 meters or whatever, right? So it kind of gets complicated and messy because there are just so many combinations and so many factors. So there's a website called as Depth of Field Masters, so dofmasters.com. You can actually log on to that website, and you can put your camera name, like Nikon, Canon, whatever you're going to using it, and you can put the name of and you can put the focal length of your lens. For example, if you're shooting at 100 millimeters or 35 millimeters, whatever, and whatever f-stop you're using, that website will tell you what is the near point and the far point for that particular lens, for that particular settings. For example, if I just have these numbers, I'm using a Nikon camera and I have 35 millimeters lens on it, and if I'm shooting at f8, then my near point will be 7.18 feet away from me, and the farthest point will be 16.5 feet away from me, which means if I'm focusing at 10 feet, then everything will be in focus starting 7 feet approximately to 16 feet approximately. So that gives me a focal range. So everything in that range will appear to be in focus, right? Now, so for every lens, so if I change this to from f8 to, let's say, f11, now my focus point from 7 feet is now changed to 6.42 feet. So it kind of gave me more wiggle room. So as you keep dialing up your f-stop, the range, the focal range keeps on increasing. and this is called as light compression. Again, another scientific name for something simple. So your light is coming from all different directions, and your lens is trying to capture them. So if you have the larger the f-stop, the smaller will be your camera lens opening, so it won't let all the light from different angles to come into the sensor. So instead, what it does, it basically compresses the light because of this narrow opening of your lens aperture. So everything, or most of the things, appear in focus. Well, on close inspection they may not be, but if you are taking a picture, looking up on your phone screen, they may look good. All right. So now, how do we focus? So let's talk about infinity focus now. How do we focus on infinity? What infinity means? So given these settings of Nikon camera, 35mm lens, shooting at f11, this website is telling me that my hyperfocal distance is 17.9 feet. Let's just keep it 18 feet for the sake of discussion. What exactly is hyperfocal? Now, it's an idea of near point and a far point, but there's a third point, which is a hyperfocal point. What it says is that if you focus exactly on hyperfocal point, for example 18 feet in this example, if I actually measure a distance from the center of my camera, which is the sensor, and measure 18 feet away from it, and if I focus exactly on that point, then everything beyond that point will be in focus, or appears to be in focus. And some people call it infinity, or focusing on infinity. So for every setting, because your range changes, your hyperfocal point changes also. So if you have a way to measure all those distances using whatever technique, then anything beyond that point will always be in focus. So how to focus on infinity? It's pretty simple. I have three methods. I'm going to talk my favorite method in the end, but I'm going to explain the most common methods that people uses. So let's talk about how we can focus on this hyperfocal point, and some people refer to it as infinity focus, or focusing on infinity. I have this Nikon lens. It's 24 millimeters to 120 millimeters, and here's the focal range on top, like this. So I'm focusing on 120 mils, and I'm focusing on 18. Well, that's fine. But below that, right here, you see a distance scale, and that's the infinity symbol. So it starts from 42 inches. 0.42 meters, which is basically, I believe it is 2 feet, right? So it starts at 2 feet, and then goes to 3 feet, 5 feet, 10 feet, and then you see this infinity symbol. So if you have a lens like that has a distance scale on it, it doesn't matter what focal range you are dialed at, what f-stop you're dialed at. All you have to do is just focus it on this infinity symbol, and your lens will always be focusing at hyperfocal. So if you're doing star pictures or planetary pictures, astrophotography, that's the way to do it if you have an infinity scale. So once again, here's the infinity scale. So all you have to do is just focus your camera, move your focus ring to infinity symbol, and that's it. Your camera will always point to infinity. So I have another lens. It is a manual lens, meaning my camera cannot really autofocus it. It also has a distance scale like this. Here's the marker. Here is the infinity symbol. So when I line up with this corner to this line, my camera will always point to, not my camera, my lens will always be focusing at hyperfocal point. No matter what f-stop, focal length, or ISO settings, white balance, doesn't matter. Well, they don't even impact your range, but just saying. So if you have a lens like this, please just focus it on infinity and you'll be all good. So that's the first method, right? The second method is, some people say like this: focus on the farther side and bring back a notch. What exactly it means? Well, I'll show you on a lens that does not have a focus scale. This is a regular kit lens that came with my camera. It does not have any distance scale on it, but my lens, if I go counterclockwise, it focuses on the near thing. If I go clockwise focusing, it focuses on the farther side. What they say is that once you reach the farther side, bring back a notch, like a tiny bit, like focus it back again. And then your lens will, and you can hope that your lens will be focusing on infinity. But why bring back a notch? Like, what does that exactly mean? The answer to that question goes back to these lenses, right? That has the distance scale on it. So I can visually show you why bring back a notch, right? Now, see this. I am focusing on, let's say, whatever, 2 feet, 5 feet, 5 feet, right? So this line is telling me I'm focusing on 5 feet. And for some reason, I want to focus this lens on infinity. And let's assume there is no distance scale, okay? If I move my focus ring, you might think that my lens is gonna stop right here and focus on infinity, but that's not true. Look at this, it goes beyond that line. You see, it's a tiny bit. It goes beyond a tiny bit. And that's why people say, focus on the farther side and bring back a notch. Now, it's not really an organic way of focusing on infinity because you don't know what that notch is. You have to do some experiment. Maybe you have to take a couple of pictures, try to bring few notches at a time and see at what point your stars or whatever subject that you're shooting far away appears sharp to you, right? So once again, you can see this thing goes beyond infinity. So when they say bring back a notch, this is how you bring back a notch. Well, I have a scale, so it's easy for me to kind of visually show you, but that's the idea. So that's the second method. You focus on the farther side, bring back a notch, and for your particular lens, if you don't have a distance scale, you might want to do some experimentation. Now, the third method, which is my personally preferred favorite method, and it has always worked for me, is using the live view, magnifying it, and then dialing down the focus, and making sure that everything, or especially the stars, are pinpoint sharp in it. For me to visually show you, obviously this is daytime, there aren't any stars at this point. I'll see you at dusk, and hopefully there's enough stars. There's Jupiter and Saturn in the southern skies, or I would say southeast skies in the evening. So I'll try to show you how I can focus on one of those planets and take a couple of pictures without changing my focus, and you will see every single star out there will be pinpoint sharp, or at least it will appear to be pinpoint sharp. And I'll also try to take kind of like a 40 minutes or 60-minute worth of shots, and then I can show you what software I use to create those star trail pictures. It's super simple. Once you know it, it may sound complicated. You don't need any fancy tools. You don't even have to buy any software if you don't want to. I personally use Lightroom and Photoshop for a bunch of other editing, but I'm assuming that many of you may not have those tools with you, so I won't be using any of those, but I'll be using a free version tool called a Star Stacks. If you want to download and install it on your laptop to be prepared, that's all good. If you don't want to do it right now, you can always wait later. So two methods. One is focusing using the focus scale, infinity focusing using the focus scale on your lens. And the second method is when people say focus on the far field and bring down a notch. What exactly it means and why people say it that way. So, all right, so stay tuned and I'll see you soon. See ya.